Our senior design team, consisting of Brittany Irwin, Thomas Kramer, Alex Pauly, and Nitsan Levy, worked with Acuity Finishing during the fall 2018 semester. Acuity Finishing, located in Cranberry Township, is a print finishing company that provides services including cutting, folding, and binding. Currently, Acuity faces a few challenges that hinder their overall production capability. During our initial visits at Acuity, we determined that the main problems they faced were late shipments. This manifested itself in a disconnect in the communication between the shipping area and the front offices. We also recognized some problems in the current shipping area layout. Labor capacity is extremely limited at Acuity, especially in the shipping area. We also observed the lengthy amount of time spent in daily production meetings. From these observations, we defined our problem statement as the difficulty in making daily production schedules and the number of late shipments for customer orders. To solve or mitigate these issues, we decided to create a system to ease production meeting scheduling and analyze the shipping area layout. After observing the production floor and talking with management, we determined that the cutting machine is a primary bottleneck. This is due to the fact that nearly every job has to be cut before it can proceed through production. We collected detailed time studies on this process to determine the flow rate for this particular machine. This, in turn, allowed us to estimate the hourly throughput and capacity for the cutting machine. To aid in the scheduling and reduction of late deliveries, we decided to use the critical ratio algorithm. This simple yet effective formula shown here bounces the amount of time left to process the order and the current due date. It then ranks the current cutting jobs in the order that they should be processed. We decided to try to minimize distances between frequently traversed zones in the shipping area. To do this, we used a mini-sun algorithm to try to allocate high-volume zones close together. This enabled us to design several varied layouts. Once we collected adequate data, we determined an approach that would best solve our formulated problems. We decided to create an Excel tool that aids in categorizing production data by client and job task. We also embedded critical ratio scheduling logic into the tool to prioritize current production jobs. This functionality is represented in a user-friendly interface. We included a facility redesign program to be implemented in 3 phases to increase ease of transitioning. The first and easiest layout to implement keeps the shelving unit stationary and reorganizes the boxing area, downsizing it in the process. The design also created dedicated staging lanes on the floor via tape to increase organization. A designated area for night deliveries is also included. The drawbacks of this layout is that the boxing area is still on the far end of the shipping area. This area also has a lot less space than the current model. The next stage keeps the previous changes but also removes the large shelving units in the middle. This increases visibility in the shipping area and allows for more mobility for forklifts. The number of staging lanes remains the same. This would be more costly to implement due to the elimination of the shelving unit. The last phase seizes all of the changes above, but also removes the boxing area. It is re-implemented on the near end of the shipping area for accessibility. All staging lanes are shipped to the right. This is the best, but also the most costly option. The customer report allows management to easily view the current jobs a specific customer has in their system. The customer drop-down list is updated based on the jobs they currently have in the tool. You can generate a new report by simply selecting a different customer and clicking Generate Report. The cutting job report focuses on cutting machine production. Pressing Generate Report pulls up all current cutting jobs and runs them through the critical ratio algorithm. The tool then displays the quantity of jobs that are overdue, ahead of schedule, and behind schedule. The recommendations are then ordered sequentially and also displayed in Excel. We decided to measure impact several ways. We determined that our scheduling tool will aid in reducing late deliveries and give more visibility when finalizing production data. Additionally, we estimate that there will be a 10 to 15% reduction in time spent in production meetings. The optimized shipping layouts will ease congestion and optimize the distance traveled in the shipping area. We would like to thank our sponsor, Acuity Finishing. We would also like to specifically thank management and the operations team. Additionally, we want to thank our 2 mentors, Dr. Lankiskorn and Dr. Vidic. The support they provided us during this project was invaluable. Thank you.